Okay, so this is Unit 8, which actually covers Chapter 20 of your textbook. So we're going to start off with looking at a little situation where you have plastic and glass rods that are fairly long, held in your hand or suspended by strings. You have wool and silk and metal spheres an inch or two in diameter on wooden stands. So initially you take a plastic rod that's been undisturbed for a long period of time, so it's just hanging there. They haven't been rubbed by anything. You just pick them up and nothing happens to either rod. You're like, okay, this is dumb. Nothing's happening. Okay, so there's no special attraction. Nothing's going on with these things. Because nothing's happening to either one of them. Nothing moves. Nothing does anything interesting. We say these both have a neutral charge or a no net charge, so no excess electrons or no deficit of electrons. All right, so then we have these two things that you rub both the hanging plastic rod and the plastic with wool, and then they move away from each other. All right, so then rubbing two glass rods with silk produces the same effect. They repel. What does that mean? It means that these two objects that are repelling each other have the same charge. So because they're both charged because something's happening, they've both acquired a charge of some sort. There is an electron imbalance. They're both charged. All right. So this also shows that this charge has a repulsive force over a distance. This is an absolutely like a field force like gravity. All right, so there's this thing called the electric force, is the force between charged objects. It's a long-range force. It's a field force, and it can be repulsive or attractive. So if you bring a glass rod that's rubbed with silk close to a plastic rod that's been rubbed with wool, they'll attract each other, which means that they have unlike charges. They are not the same charge values. Okay, so there are two different charges, two different kinds of charges, positive or negative. Okay, so they're opposite if they attract, and hopefully you know this, that opposite charges attract unlike charges. Or unlike charges attract, opposite charge. Try that again. Unlike charges attract, like charges repel each other. So again, if they're held farther away, the force between them decreases, kind of like the force of gravity that we talked about it in the first semester. And the more you rub it, the more charge it gets converted. So it acts over a distance. Okay, so a charge diagram shows the charges in a particular object. So if you have a positive and a negative charge, and you bring them near one thing that has a positive charge, the other one has a negative charge, you bring them near each other, they're going to attract each other. More positives or more negatives equals more of that charge. All right, so if we start with a neutral uncharged hanging plastic rod and a piece of wool, and you rub the plastic with the wool, then hold on to the wool close to the rod. The rod is attracted to the wool. So what does that mean? They're oppositely charged. Okay. So we know that from earlier on, we know that the plastic rod has a negative charge. So because the wool attracts the rod, the wool has to have a positive charge because opposite charges attract. So when a rod is rubbed by wool, not only does the plastic rod acquire a negative charge, but the wool acquires a positive charge. So here's how you think about this. The rod actually gains electrons from the wool. Okay, since the rod becomes negative, it actually acquires electrons from the wool. Since the wool has lost negative charges, and it was neutral, it is now positive charge. Okay, again, an object becomes positively charged. The amount of positive charge on it exceeds the amount of negative charges. So neutral means that there's even amounts of positive and negative charge. You rub them together. Now one becomes more positive and one becomes more negative. Okay. So the wool loses negative charge. The rod gains the negative charge. So instead of both being neutral, now the rod is negative, the wool is positive. There's this idea, all this follows the law of conservation of charge, just like the law of conservation of anything else. Charges are neither gained or destroyed, they simply change from one place to another. So in these cases up here, the total number of charges are the same. It's just that with now over here, they're more of the negative charges are here, the net positive charges here, but the total number of charges in number 5 is the same as in number 4. So when you like rub a balloon on your hair, you comb through your hair when it's really dry out, and your hair can kind of stand up with the comb that's static, is a transfer of charge. Right? So basic model. So friction adds something called a charge to an object. There are two types of charges, positive, negative. Two objects with like charges repel. Two objects with opposite charges attract. And these are called electric forces because you're dealing with electrons and the number of electric charges. So the force between them are long-range forces. Neutral objects have an equal mixture of positive and negatives. And the rubbing process charges the object by transferring charge, usually the electrons from one object to the other one. And energy, or the charges, cannot be created or destroyed. They just change from one location to the other one. All right, so now they talked about at the beginning that they had these little metal balls. So you have a charged plastic rod and the metal. And when they touch, the metal sphere acquires a charge. So you charge a plastic rod by rubbing it with wool, touch a metal sphere with the rod. The metal sphere then repels a charged hanging plastic rod. So the metal sphere appears to have acquired a charge of the same sign as the plastic rod. Now, if you place two metal spheres close to each other with a plastic rod in between them, if you charge this one over here, okay, after the metal sphere that was touched repels a charge hanging plastic rod, and this sphere does not. Okay. What is going on here? So now repeat experiment 7 with the metal rod connecting the two. So this one was plastic. This one was metal. So we're going to repeat this one. The plastic rod between them. So place two metal spheres. Charge a plastic rod by rubbing and touch it to the metal sphere. Afterwards, the metal sphere that was touching the sphere repels a charge, but this one remains neutral. Now we do the same thing. We charge a plastic rod, but now this time there's a metal rod between the metal spheres. Now this time both metal spheres repel a plastic rod. So that means on both of these are getting a charge. So again, we're talking about insulators and conductors. An insulator does not allow charge to move through easily. It stores the charge on it. A conductor moves the charge, allows the charge to move on it or through it. Okay, you've probably heard that term, hopefully. But yeah, insulators hold charge, conductors allow charge to travel through. Okay. So conductors move through along which charges can move easily. Insulators hold it. Metal's a good conductor. It allows the extra electrons to move through it. Glass is an insulator, keeps it held tight. Now there's this thing called electrostatic equilibrium. It happens when the charges are at rest. And a conductor in electrostatic equilibrium allows it to move briefly. And these charges move really, really fast. Okay, so like when you rub two things together and the charges move, you can't really see it because the charges are moving so fast between them. Electrostatic equilibrium kind of makes it sound like hopefully what you would think. We have an equilibrium, we have a balance of electrostatic forces. Now, there's part of this is called charging by polarization. When we're talking about all these the plastic rod touching something. So is a slight separation of positive and negative charges in a neutral object when a charged object is brought near to it. So we have a neutral sphere that has the same number of positive and negative charges. But if you bring a positively charged rod towards it, the sphere doesn't gain or lose charge. But what happens is these negative charges that are the opposite of the positive charged rod move towards that part of the sphere. So right now, this side of the sphere has a net charge on this side, but it's still, the whole sphere is neutral. When you take the rod away, the positive and negative charges go back out to equilibrium and they balance out. But this polarization piece means, like it shows, negative pole, positive pole of this sphere. But it's a momentary thing. Okay. So there's a net attractive force, and the positive charges are repelling the like positive charges, and the negative charges are attracting. Okay, they're slightly separated. Okay, and all right. So section 2, kind of a little bit of chemistry here again for you. So an electric charge is abbreviated by the symbol Q. The unit is a coulomb. And one electron has a charge of 1.6 times 10 to the negative 19th coulombs. So one electron does not have a whole lot of charge. So just kind of show you again. Protons and electrons have the same numeric value for charge, but the electrons are negative and the protons are positively charged. Masses, they are quite different, heavily, as you know from chemistry. Protons are quite a bit heavier than electrons. All right, so an atom has dense nucleus where the protons and neutrons are. Then you have the electron cloud around it. So charge-like mass is an inherent property of electrons and protons, as we showed you earlier on that slide. So electrons and protons are the basics and charges in matter. These are the sources of the charge. Okay, and a charge just means you have an unequal number of protons and electrons. If you have a negative charged object, you have more electrons than protons. Positively charged object has less electrons than protons. So objects become positively charged because they lose electrons from the electron cloud. Electrons are more easily moved than a proton, so they are essentially the currency for electric charge. So if something becomes positively charged, it has given up electrons to something else that has now become negatively charged. And that is the end of this part 1 video. Make sure to write any questions down you have on the bottom of the Google form, and we'll see you in class. Bye-bye.